हेलो अस्सलाम वालेकुम। आवाज आ रही है? जैनब इबाद आवाज आ रही है?
जी सर।
ठीक है, एक second। अच्छा चले, रेट ऑफ रिएक्शन, ठीक है। वो स्टार्ट करने, ठीक है। रेट ऑफ रिएक्शन, ठीक है। रेट ऑफ रिएक्शन इज, अच्छा एक, इट्स अ स्मॉल टॉपिक, रेट ऑफ रिएक्शन। तो we'll probably be done with this very quickly. अच्छा, so rate of reaction is, okay, the first thing that we need to understand is, okay, what is rate? So what is rate? Rate is any change that's happening when you measure the change with respect to time. So it's a change, and it could be anything that could be changing with respect to time. ठीक है, so it's delta change versus delta t. ठीक है, that's what rate is. और ये जो change है ना, this change could be, it could pretty much be any change. कि in a reaction, a lot of things are changing. It could be a color change. If the color change happens very quickly, मेरी tablet disconnect होगी, एक second. Just give me 1 second. Just a second. अच्छा चलिए, sorry. I got disconnected again. Uh, can you hear me now?
Yes, sir.
Okay. Okay, so I was explaining, okay, what is rate? Rate is any change with respect to time, and I told you that in a chemical reaction, this change could be any change basically. It could be a color change. If the change happens very quickly with respect to time, then it's a fast reaction. If it's happening very, very slowly, then it's a slow reaction. It could be a change in mass. It could be a change in volume of gas. It could be uh, a change in pH or concentration, or the amount of bubbles that are being produced. So anything that happens that is observable and measurable. Remember, it has to be. When you can't, if you can't observe it or you can't measure it, then that change uh, wouldn't really matter because then it would be pointless to you. So it has to be something that's observable and measurable. So rate of reaction, that's what rate of reaction is. So if I do a chemical reaction and I'm going to, and if I ask somebody to measure the rate of this reaction, so there are plenty of things that he could do to measure the speed of the reaction. The first thing is you always need a stopwatch for this, right? So stopwatch is always needed. So if I have this reaction It's Mg solid, which is a metal, and it's reacting with aqueous HCl, and it's producing aqueous MgCl2 plus H2 gas, right? So if we do this reaction, what happens is that there are many ways of doing this reaction. For example, there's HCl. HCl is a solution. So you're going to take this HCl solution and you're going to place a piece of Mg metal. So the metallic strip of Mg is going to be placed inside it. And immediately what you would notice is that they will start reacting, they start producing salt plus H2. So you would notice a lot of bubbles getting formed. So what could you do? What would you measure with respect to time? You could measure, number one, the change in mass of Mg. For example, what you can do is like after every 1 second, you can take out the piece of Mg and weigh it. So the change in mass of Mg could be plotted against time. So that is one thing that you can do, and you can make a graph out of it, and the graph would look something like this, that you have time on one axis. One axis would always be time in seconds, and on the other axis you're plotting the mass of Mg. And what's happening to the mass of Mg? It will slowly decrease. And reactions normally are very fast in the beginning, so initially it will decrease very quickly, and then the reaction will start slowing down, and maybe the acid gets used up, so it might stop decreasing after a certain amount of time. So is this clear that this is how the mass of Mg is going to vary with respect to time? Is this clear?
Yes, sir. It's clear, sir.
Okay. Zainab, Taha, Ibad, is this clear?
जी सर
Achha, so this is a change versus so that's your change that's plotted over here. The mass of Mg versus time. Now in this specific graph, remember the gradient is basically the rate of reaction. Your gradient or the slope or the steepness of the graph is basically equal or proportional to the rate of reaction. So the steeper the graph, the faster the reaction. Make sure you remember that. So steeper means it means you're going to have a faster reaction the steeper it is. And so that is one thing that you can do. And the change could be an increasing change, it could be a decreasing change. What else you can do is you can measure the volume of H2 gas. I mean, what you can do is you can collect the H2 gas that's being produced over here. So for that, remember in ATP, especially in ATP, you would be asked to make sketches as well of the apparatus. So for that, what you can do is you can have a conical flask, and you can collect the gas that's being produced. And it could be collected probably in a measuring syringe. And this is a sealed apparatus. And you've got HCl aqueous. So any gas cannot escape. So this is a rubber bung to seal the apparatus. And now you have to put a piece of Mg into it. What you can do is there are many ways of doing that because you can't open the apparatus. So you have to put in a piece of Mg. So one way to do that is you will have a tube. One way to do this is you can place Mg in a bottle, in a tiny bottle, and that bottle contains, let's say, Mg coil that's placed in it, and you can tilt the apparatus so it falls into the acid and the reaction starts. And all the gas that's going to be produced is going to be collected in the gas range over here. Now, the way this graph would look like is because it's an increasing change, which means that initially you didn't have H2 and then H2 started forming, right? So this is the volume of H2 gas. And so H2 gas is going to be produced, and then at a certain point it's going to become constant. And this axis, you've got time measured in seconds. So any change that could be measured with respect to time and can be plotted on a piece of graph paper. And it could be an increasing change. For example, the mass of Mg is decreasing. So what you can do is you can take out the Mg, wait, then put it back in, then wait again every 5 seconds. Or what you can do is you can measure the volume of H2 gas. I mean, there are other things as well. You can measure the amount of bubbles forming, right? I mean, take a picture after every 5 seconds, and maybe there's a computer program which tells you the total number of bubbles in the solution. So maybe there are 20 bubbles, then there are 10, so the reaction slows down. So is this thing clear, how to make the apparatus and how to measure the rate of reaction in an experiment? Is this clear? The Bira, Zainab, Taha, clear है ये बात? अच्छा, अब the next thing is okay, we've got as the next thing is you can, I mean, this graph is like really important because it kind of tells you the way the slope of the graph is changing. So it was very fast, then it kind of slowed down, and a flat line indicates that the reaction pretty much stopped. So steepness is the speed of the reaction. Now, instead of plotting a graph, what you could also do is so instead of plotting the graph and knowing the speed at every second, at every time interval, I mean, like the way it's shown in the graph. I mean, that's one option. So instead of plotting the entire graph and knowing the speed at every time interval, what you can also do is you can, like a 100-meter race. TK, for example, if there's a 100-meter race, it is the Olympics. No one measures the speed at every time interval. What they simply do is they set a mark. Whoever reaches that mark first wins. So rate is basically inversely proportional to time. The faster you are, the lesser the time. So what you can do is you can keep the change as long as the change is constant. So you don't always have to measure the change. I mean, runners bhag rahe hote na in a 100-meter race, so no one is actually going there and measuring their speed in meters per second. The only thing that they measure is time. They just keep the change constant. Like everyone has to run 100 meters. So the same thing could be done with the experiment as well. Everyone has to produce 100 cm3 of H2 gas. Or everyone is, all the reactions, whatever the comparison is done, all of them, I mean, this is helpful when you are comparing multiple reactions and the speed. So if I have this apparatus, I'm just going to put a mark over here. Whoever gets here first, I'm just going to start a stopwatch. If this amount of H2 gas is produced, I'm going to stop the stopwatch. So the one who's the fastest will take the least amount of time. So if you're comparing different experiments, you can set a mark in the experiment and just measure the time, and rate of reaction will be inversely proportional to time. ये बात clear है? Labira, Zainab, Taha, is this clear? ये बात clear है? Taha,
Yes,
is
sir.
this clear? So this one is, example is that whichever reaction produces H2 gas quickly. So those 100-meter runners, they just measure their time, that's it. They don't measure their velocity. They don't do any math calculation. They just measure the time, that's it. The lesser the time, the faster you are. So rate of reaction or speed of reaction is inversely proportional to, it's inversely proportional to time. I said, moving on. This gives you some idea about how the apparatus should be drawn. And it's basically just common sense. If you're used to apparatuses, you got to figure this out, that you have to measure some change, but with respect to time. Next thing is now we're going to talk about kinetic particle theory and the rate of reaction. What happens in this is you've got basically all molecules and compounds, they all could be considered as tiny particles. So if particles of A and particles of B react, okay, so there's a bunch of particles, there's another bunch of particles. Now these two are reacting together. The reaction happens when particles collide. Collisions between particles and because of that you have a chemical reaction. What happens in a chemical reaction? The old bonds are broken. And as a result, new bonds are going to be So new bonds are going to be formed. Old bonds are going to be broken and new bonds are going to be formed. And that results in new products forming. So, but for that, you have to have collisions. And the rate of reaction depends on two things. The collisions have to be thought of in two ways. Number one, how frequent are they? So it depends on the frequency of collisions. And number two, it depends on the effectiveness. Frequency is the number of times that they collide. And the other one is the effectiveness of the collisions, which is how forceful are the collisions? Can they break the old bonds? Okay, which is why normally at lower temperatures you don't have a very fast reaction. Why? Because the particles are not just energetic enough to break the old bonds. The frequency of collisions and the effectiveness of collisions, or the success rate of the collisions, or the forcefulness of the collisions. Anyway, so always remember the rate of reaction has to be described in these two terms, frequency and the proportion of effective collisions. बल्कि proper word है proportion of effective collisions. The frequency of collisions and proportion of effective collisions. अच्छा, so there are 5 factors that affect the rate. Starting with the first one. So the first one is, so number one is temperature. Here, that's number one, temperature. And temperature is that the higher the temperature, that would lead to greater kinetic energy of the particles. They'll move quickly. So that leads to greater kinetic energy. Particles travel quickly, so that is why you're going to have more frequent and effective collisions. That leads to faster, hence faster reaction. So particles are not only traveling quickly, they'll be colliding with a lot more force, which is why the collisions are going to be very, very effective as well. ठीक है? ताहा नबीरा ये बात ये clear है?
जी सर.
अच्छा, but second क्या है? Second is pressure. अच्छा, but pressure is only for gases. As gases compress. So this is not going to be a factor for solutions or for solids or liquids. So when you compress something, what happens is, okay, let's say there's a So let's say there's a piston over here. So now when you compress something, the particles will become closer to each other. So if the same container is at a higher pressure, you're compressing it, and all these particles are now, so all these particles are now a lot closer to each other because you have compressed it and the volume has decreased. Okay, so this is the same thing at higher pressure. So when you take a gas to higher pressure, the volume decreases. And because of that, particles are closer to each other. And because they're closer to each other, so they're going to have, they'll just bump into each other a lot more, hence more frequent collisions. But the proportion of effective collisions does not change. ये percentage कर लेते हैं. The percentage of effective collisions it doesn't change. Which means that they're not becoming more energetic. So the forcefulness of the collisions or the speed with which they're colliding with each other, that kind of remains exactly the same. The only thing that's happening is that they're just closer to each other, which is why they are going to have more frequent collisions. लेकिन वो जो percentage of effective collisions, that does not change. ठीक है, is this clear? भैया Taha Ibad, is this clear?
जी सर.
Or next is number 3. Okay, that's concentration. As a concentration is that you have, this is only for solutions. Or could be gases as well. Concentration, like pressure, is something that's very similar. That you got a solution, and it could be a dilute solution where you have particles, but there's more water, right? The other one is that you could have a solution that is more concentrated, which means that there's more particles per unit volume. So one of them has a higher concentration. So that basically means you have more particles per unit volume. And if you have more particles per unit volume, that means you will have Again, you have more particles, so they'll bump into each other a lot more. And you will have more frequent and effective collisions. Okay, the more frequent, but the proportion or the percentage of effective collisions, it does not change. Okay, is this clear? Daha, Damira, Imad, clear है?
Yes, sir.
Okay, so that's concentration. Solutions having higher concentration, they're going to have fast reactions. So they will have faster reactions. Number 4 is a catalyst. So what will a catalyst do? A catalyst is something that reduces the activation energy of the reaction. So it's something that reduces activation energy, which is EA. What is activation energy? It's the amount of energy that's needed to start a reaction. For example, you need to strike a match so that it starts burning. So amount of energy needed to start a reaction. And why do you need energy at the start? Because you need to break the old bonds. For example, there's oxygen gas molecules everywhere around you. Okay, so there's now oxygen causes combustion. Things burn in oxygen, right? But oxygen is kind of inert because if this oxygen molecule is flying around and bumps into the wall or any place, it's got a very strong double bond, which is pretty hard to break. So if the oxygen molecule is moving very slowly, it has very less kinetic energy. The oxygen double bond oxygen is not really going to break, which is why the oxygen will not be able to react. But if oxygen has a very high kinetic energy and it bumps into something and its bonds break and the two oxygen atoms are now independently flying around. So now what will happen is that there's a pretty big chance of a reaction that might take place. It's because the old bonds have been broken. So amount of energy needed to start a reaction. Why do you need energy at the start of a reaction? To break old bonds. So unless your old bonds are not broken, so a catalyst does that. A catalyst is a substance that kind of weakens the old bonds and makes it easy to break. So it reduces the activation energy. It reduces the amount of energy that is initially needed to start a reaction. The other properties as well, it remains unchanged during the reaction. So, and provides an alternate route for the reaction to happen. So it provides an alternate route for the reaction. So that is how a catalyst is going to work. It reduces activation energy. And because of that, what happens is, okay, what's going to happen is because of that, reduces activation energy. The frequency of collision remains the same. You're going to have a higher proportion of effective collisions. More collisions would be successful. So you will have more successful collisions. The old bonds would be more easily broken, while the frequency of collisions would remain exactly the same. So maybe you're having 100 collisions per second. After adding a catalyst, you're still having 100 collisions per second, except that they're more successful now. You get Taha, is this clear? Nabila, is this clear? Ibad, is this clear? Yeah, Taha, is this clear?
Yes,
Yes, sir.
चल ठीक है, we'll continue tomorrow then, ठीक है? Okay then, everyone. Take care, Hafiz.